Please, the floor is yours.
Nice. So I will share my screen, okay, and show my presentation I prepared. Okay, so firstly me present myself. So my name is David. I'm presenting. This is our presentation from Lutsk National Technical University. Also, web-based approach for it has named the web-based approach for assessing CO2 emissions during the Russo-Ukrainian War. So this presentation is based on and inspired by our team that we prepared because of the huge pollution of the missiles and the contamination of the earth of the Ukrainian earth with the military shells. So that's a very huge problem in Ukraine, and this exactly relates to our presentational problem. So I will start my presentation firstly from on counting the consents. The first consent is motivation and state of the art. Objective, the second one is objective of the research. Third one is the main result. Fourth, the case study. And five will be the conclusion of my presentation. So let's start from the motivation. Part of the motivation I've described it previously, but here you can see the graph. That's a graph named the emission for the host on the territory of the Ukraine. Here you have very, very huge numbers of the emission that was released after the war started. And here we have several of the points related to that. The main point, as you see, it's a CO2 carbon emission based on fuel consumption by Russian troops. Here is a 14 more than 14 million tons of CO2 emissions, and this is exact values that was calculated from the general open sources. By our data, as we investigate, this number is much more than it was investigated like during half the year ago. So that's increasing very fast. And the second after that, as we see, is fuel consumption by Ukrainian troops. Our troops, of course, the best troops for our case, but anyway, because of the uh, real like facing the attacks, our troops also spending a lot of fuel and also do the pollution, but of course much more increased way than if we compare with the Russian troops. And of course then we have the ammunition using. That's a lot of, we even don't include like the pollution based on some plastic, on some missiles and so on. That's the second part. We're talking only about CO2 emissions. So that's weapons, that's grenades, that's some small missiles and so on. That's very huge amount. So here you can see how much it is, and it's only from this graph we see it's about 20 million tons of carbon emission. So that was our main motivation to create such investigation, to help our science team, to help somehow our Ukrainian pollution to retreat after the war end and during war currently. Let's move forward to next graphs. So here's, for example, annual war-related changes in the EU energy sector. You can see how European Union is upgrades their emissions, and they upgrade their practices in all stages. For example, they are changing and like a lot of energy to natural gas. You see the next point is gas to oil switching, electric power industry, and transition to liquefied natural gas. So the most efficient, as you see, it's using the natural gas. It decreasing the 64 millions of tons of CO2 emission. That's very efficient. So yeah, we can move forward. For example, we can see also the graph you see the below, the emissions of greenhouse gases due to the reconstruction of the civil infrastructure. So basically, In this stage, we don't include, of course, pollution of burning of a lot of like the houses, a lot of infrastructure. The very big tragedy. So in Ukraine, a lot of houses, a lot of buildings was simply destroyed. A lot of leakage of the gas of a lot of stuff. That's very big problem. But here's we see the graph that shows us how do we spend and the like we produce carbon emissions during the building and renew and simply the infrastructure that was destroyed. That's even not the new infrastructure. So let's move to the next stage, is the objective of the research. So the purpose of the research is to develop a web service that allows accurate calculation of carbon emission, CO2, and providing the recommendations for their reduction using modern data processing technologies and analytical methods. That's a very good point, I think. So main results, we can see four of them. Yeah. So math balance approach. We can see, like, for example, the approach that was used, the methods, modeling and simulation, chemical absorption methods, and the use of international standards. So let's begin from the mass balance approach, MBA. We have several advantages and disadvantages. So our approach like is based on MBA. So let's discuss firstly about advantages: high accuracy for calculation in industrial conditions, and the disadvantage as requires accurate data on the amount and chemical composition of the fuel consumed. So it means like we can calculate more detailed specific case, but we need more data based on this. So we can calculate the gasoline basically, yeah, what was produced, but we need like a bit more specific in the data because like that's important for our calculations. Yeah. So suitability for emission analysis at large facilities for system with a known fuel consumption characteristics, and the disadvantage is the difficulty in applying to emission sources where accurate fuel consumption data is difficult to obtain. So that's because we have a war, and it's a complexity of make some statistic. All the statistics, as you know, are very, very approximate. We don't have some exact values. Yeah. Empirical methods. So basically have some opposite approach. So it's easy for use, but the disadvantage is a lower accuracy compared to mass balance approach. Yeah. And a convenience for broad assessments of policy analysis at the region level, but limited applicability to a specific process or conditions. Let's go faster through the modeling and the use of international standards. So we have modeling and assimilation of chemical absorption methods. So how accuracy and needs of the details, data and technical knowledge, and talk about the use international standards and ensures compliance with the regulatory requirements and required details, data collection and documentation. I would not say that's a disadvantage, like it's a more make it more sustainable and standardized, but anyway it add more time and resources needed to calculate. So this we have like basic comparison and ease of data comparison between different organizations. That's an advantage, and a disadvantage, it can be difficult to implement in small organization without adequate support. So basically, as we weren't on such big trouble as a Russo-Ukrainian war, to be correctly, it's not our case. So yeah, we can move forward. This we see like the application in general was implemented using the like modern tools. The front-end side was implemented by React.js framework. The back-end side was implemented by Node.js, including AWS Lambdas. For modern scalability, it's a serverless architecture, very easy to maintain, and also Lambda's serverless architecture provides a lot of for startups. AWS provides a lot of certificates to make it like cheaper or free even for the beginning. Basically, you see basic architecture, and the main idea was to make it simple and to make it, of course, like efficient. Yeah, because anyway, it's, if we discuss in the startup dimensions, it's a seed stage only. So case study. So we have a comparative results analysis of the correctness of the system operation with the expected values. It was investigated and made some calculations based on our system. You will see the screenshots on the next slides. For example, was done by propyl carbon emission and acetone. So like it was several fuel types, like a petrol and a diesel. Here you can see the comparison of that. Let's move forward. So this is how our system looks like. I would say that in general, that's only small part of the system that we have, but we have like the general, of course, login in. We have an admin panel. We have several roles that can be that is basically the B2B solution can be for the businesses to make the easier calculation of the carbon emission. This you see the basically the tool that make possible for user to write the values, calculate based on this, display the emissions, provide some user remarks, and so on, and then see general statistic and calculations. So this is data entry for acetone, by the way, as you see here. The functionality of the development production is briefly described below. I'll probably go through this, try to do this fast. List of assets, the system function, it allows to add and edit assets and assign them different accounts to track emissions. So basically that's how I described it a second ago. The interface convenient for viewing and managing a large number of assets. Here, for example, you see the beauty of the current interface, right? So a list of assigned assets, the system function displays all assets assigned to different companies with the ability to filter by dates and other parameters, so basic filtering and so on. The interface simplifies the control and monitoring of emissions for each asset and allows you to quickly find the necessary information. That's a very important point, yeah. Also asset management interface. I'll not go through each one, but anyway, you can edit, you can add assets, you can manage them, you can filter, assign to some business can see the calculation. That's a good point for Ukrainian businesses, for example, to also track their pollution and carbon emission. And of course, there's also contributes to some governmental structures. And then the filtering again was mentioned as a basic display filter the data that relates to some business or some organization or some type of pollution. Analogy list, I would say that we have a lot of different analogies. Our system is not unique, of course, right? But as an analogy, I would say, so I would say several examples. For example, one of them you can know the GreenFi. That's a very interesting business, by the way. I has some relation to that. That creates a international banking system for make sustainable products based on CO2 carbon emission. So basically, one of the main points of like businesses when they looking for optimization of carbon emission, that they're looking for sustainability, because like I'm right now placed in Estonia and I'm also inspired of how do they do the business here, and the business is very interesting approach. They want to be sustainable for long-term relationships, for understanding that everything is built properly, that everything is related to carbon emission, also included into the process of development. All the chain should be included and implemented as well. That's a way how European countries, how the first countries in the world cooperating. Unfortunately, Ukraine not the first stage country. It's not tier 1. Ukraine is tier 2, I believe, not tier 3. And we need to go in this way and understand how sustainability will be integrated to our business models, including our complex situation with carbon emission, including war. Also, we have basic analogies as a cool set, as a watershed, as a Persephone. So basically, it's a lot of them. As I said, like GreenFi, as a business banking orienting sustainability application to maintain the carbon emission. So there are a lot of them, and that's very important to use and integrate in your business. If somebody has a business in Ukraine from here, very important to understand how it will lead to upgrade your level of business for European clients and partners. That's very important, not only for our nature. So let's move to the conclusion. So conclusion, the web service has a potential to be scaled and implemented in various industries and featured the occupied territories. Of course, I said about business because I'm a bit more integrated to business, but again, our main point is war and how we will handle the occupied territories industrialization, rebuilding everything there. It's very important point. So this presentation represents our approach and vision. In connection with the duration of the war in Ukraine, the problem of even greater assistance in the fight against climate change, environmental, and the reduction of global greenhouse gas emission areas. Ukraine plans to implement the Environment Compact. The action plan contains 66 points of the assessment of environmental damage caused by Russia, punishment for committed crimes, and the elimination of the damage caused. These steps are planned to be completed by 2027. Of course, it's a good scenario. Most of them are going to be implemented in 2024. Probably this, I would say, the final implemented some points 2024 and main points in 2025. Yeah. For this purpose, 28 ministers, centralized the executive bodies, and other organizations will be involved. So what I want to say from my side also, I would add that we need to understand how we will cover the occupied territories, how we will make our vision for the business and for young startups, and build a sustainable country approach with understanding and implementing proper CO2 carbon emission, calculating and reducing. So thank you for your attention very much and have a good day. If somebody has some questions, please ask. I will be open for them.
David, thank you very much. Maybe questions for our audience.
Yeah. So please ask.
Okay. Yeah, I have a couple of questions. What is the scale for your solution? You didn't mention. For
Scale?
whole country, for Volhynia.
Yeah, basically, as I said, okay, I'll answer. Thank you for the question. So basically, the scale of this solution, it's multiple approach. This mainly directing to some localized, like companies, business, or governmental organizations. That's not all the country covering calculations. We don't calculate in our system how much tanks was through the emission in our system, and did the pollution to our country. But we can calculate exactly for like some local businesses, for governmental structures, and provide to the governmental structures a tool to calculate emissions also from basically from the war pollution. So our tool is possible to use also for calculating, for example, it's a military structure that calculates for some region, the occupied region, the harm that was done by Russian Federation, like destroying houses, gas emission, and so on. This can be used also. So that's
it's clear that you built some web services and this some kind of automata input. If you have input data, you have some solution. So the next question is which exactly input data did you do that?
Which exactly, basically we have open sourced data, from there are a lot of information in the internet you can see that represents, for example, emission by 1 kilogram of propyl of different gases. That's a very open information, and our system, based on that, we have some amount of value of the exact type, or like average approximate value, and we calculate based on this stuff. So we calculate an open.
Usually we have some scale, for example, 1 kilometer by 1 kilometer, some square rectangle, and for that rectangle you have some value of CO2 emission or concentration. And what's the next step? if you should to calculate some emissions for, you have some value for again Volyn region, and but you should calculate the same value, for example, for Kharkiv region. Is it possible?
Yeah, it's possible, but again, one of the point I've mentioned, that's let's say approximate values. If we discuss in the, we're discussing right now about kilometers of tanks, right? So how can be this calculated? Only like by general info that was done by, I think, military science group that came to after occupied territory, generally calculate amount of kilometers that tank bypass. We calculate average amount of emission of firing the fuel per that kilometer for tank for this zone, and then calculate based on this gasoline type the emission of carbon. So that's very, very general, but anyway, it's possibly to calculate. So I think the main point we need to understand that calculating the carbon emission in war situation exactly during war crimes and so on, that's not the most important thing. I would say that our tool mostly oriented on the like more sustainable approach, like for businesses, companies after like the occupied territories, because to calculate real but battlefields emissions, that's simply impossible.
Yeah, it's clear. We don't have time to talk in
Of
detail.
course,
Yeah, but nevertheless, what do you think that your model are accurate?
I think.
How you validate it?
Yeah, I would validate. I would answer in the business side. Why? Because like our approach, I again integrated this approach from several similar businesses that also providing calculations, and they do. If we use exact values, we have some statistic, and we have, for example, company that provides such amount of gasoline. Yeah, or like we know how much our tank, for example, we discussed about war, emits the fuel on this current road. If we have a pretty exact data, even like such approximate, we can calculate very, very strict exact data. So I would say it's about 75% of accuracy. In this case, that's very accurate, but it's still that point that we need. If we discuss about sustainable business that has a proper statistic, a proper bills of all emissions, it can be about 90% of accuracy.
Okay. Okay, I think we should stop because it's very interesting, and yeah, it's a lot of questions. It's not for business, of course, because if you have model, you should deal with model, with mathematical modeling, with input data, with correctness of using this data, and so on. It's not the business. Business later. Business users of your user of your results. But before this, you should demonstrate accuracy, completeness, and so on. So it's some objective things, from my opinion. But it's just talk. So thank you very much. Maybe somebody else would like to ask to continue on this topic. Okay, if not, time to go. Thank you, David, one more
Thank
again.
you.
Yeah, for good presentation.